So this is an electrochemistry question, and the question says, use the standard electrode potentials in the table below to answer the questions that follow. An electrochemical cell was set up based on systems 1 and 2. Write half equations to show what has been oxidized and what has been reduced in this cell. So before we can do that, we need to work out one of these reaction goes forward and one of these reaction goes backwards. Look at the electrode potentials. Remember that the most positive reaction goes forward. So this reaction and this reaction, which is the most positive electrode potential? So for the vanadium, the E0 is minus 0.26. For the iron 2 plus, the E0 is minus 0.44. Which is the most positive? The most positive is this value. It's least negative. It's the least furthest away from 0. So that means this reaction goes in that direction. If that reaction goes forward, this reaction goes backwards. So if this reaction goes forward, it's gaining electrons, and that means that reaction is being reduced. If that one is losing electrons, the iron's going to go to Fe2 plus 2E minus. That must be oxidized. So the oxidation is Fe solid goes to Fe2 plus aqueous plus 2E minus. And the reduction, the most positive goes forwards, is V3 plus aqueous plus an electron goes to V2 plus aqueous. Because the most positive goes forward, the least positive goes backwards. It says determine the cell potential of this cell. So the cell potential of this cell is that value there. That reaction is going forwards, so it's minus 0.26 volts. And that reaction is going backwards, so it's the opposite sign of that. So it's minus 0.44 volts, which equals plus 0.18 volts. Why do I make that negative? Because that reaction, the vanadium reaction, goes forwards, so we leave that value as it is. But the iron reaction goes backwards, so we need to take the negative value of that E0.